Hi, I'm Casper, a robotics student at WPI, and today we're going to begin a series of videos about the lab equipment that's available for you to use on campus. Today, we're going to step through some examples about the benchtop oscilloscope and function generator that's available in the robotics lab. These tools are ubiquitous in robotics, and they'll help you test your circuits and analyze them. A function generator or signal generator is a device that outputs voltage functions over time. We can choose between square, triangle, and sine waves. The device uses resistors, capacitors, and diodes to achieve these mathematical approximations. We can manipulate the wave's amplitude, frequency, and duty cycle using some of the knobs shown. Let's start by generating a sample 75 Hz square wave. Let's start by powering the device on. There. Now we're going to choose a square wave, and we're going to set our frequency. Because we desire a frequency of 75 Hz, we're going to choose the scale that's just one order of magnitude above our desired frequency. So for us, this is 100. Now let's make some coarse adjustments using the large knob, and some fine adjustments using the small knob. There. Now we're at approximately 75 Hz. We can choose the amplitude using this knob, and the duty cycle using this knob. Because we don't have an external device, such as an oscilloscope, to truly observe our wave, we won't be able to see the changes that we've just made. Now that the benchtop equipment is properly set up, let's try to grab our signal using the oscilloscope.
The oscilloscope is used to measure electrical signals over a known period. Usually, this is shown as a waveform, or a plot of the voltage over time. In other words, the oscilloscope is a useful tool to show a real-time graph of the signal from any point on your circuit. Here we've set up an RC circuit that uses the 75 Hz square wave from the function generator as an input. Let's try to use our oscilloscope to measure and analyze the output. So here we have our RC circuit on a breadboard. First, we'll attach the output from the function generator to the breadboard. Notice we have this jumper wire. That makes it nice and easy for us to attach the oscilloscope. The oscilloscope uses a probe that connects to a point on the circuit and its ground reference. The witch hat, as it's called, can be pressed down, exposing a hook to connect your signal voltage. The black alligator clip is then connected to ground. Let's move over to the display to start analyzing our waveform. Before we try to adjust the display manually, let's press the auto button to automatically adjust our scales. With that out of the way, let's see if we can get some information about the graph. To do this, hit the measure button, and then hit display all on the submenu that pops up. From this, we can confirm that our frequency is just about 75 Hz. Sometimes though, you'll want to tweak the waveform to your liking, so let's try to adjust this signal manually now. Taking a look at the display, you can see that the screen is subdivided into blocks composed of dotted lines that partition the vertical and horizontal scales. The vertical scale and position can be adjusted using these knobs, while the horizontal scale and position can be adjusted using these knobs. Using these knobs, we can get a better fit of the data. The horizontal scale knob controls how much time each little block on the screen takes up. The horizontal position knob can be used to shift the waveform back and forth. The vertical scale knob is used to control how many volts each block represents, and the vertical position knob is used to shift the waveform up and down. To get an idea about how to measure two signals at once, let's configure the oscilloscope to display a second waveform. For this example, we'll use a second probe to measure the raw output of the function generator. This way, we can compare the output of our RC circuit to the original signal. We'll start by modifying our existing circuit on the prototyping board. We'll have the output of the signal generator split into two parallel branches. One will contain a resistor and capacitor in series, as was done before. The other will just be connected to the oscilloscope.
After connecting the second probe, you should see something like this on the oscilloscope display. Let's adjust the scaling and position so that the waveform can be easily compared. With that done, we're ready to take a screenshot of the display so we can use it later in a lab report. In order to do this, you'll need a USB thumb drive. We've connected ours to the port shown here. Next, you'll select Storage, And using the top blue menu button and the selection knob, you'll want to change the storage option from waveform to bitmap. This will give us an image file that is easily pastable into any document. Now we'll select External, and we can choose to rename our file. Instead, we'll keep the default and just choose New File. So now you'll click Save, and the picture will begin to save. There, New File 0 bitmap has appeared on our USB flash drive.